Hi, sixth graders, this is Mrs. Gall. Today we're going to talk through converting decimals and fractions. Go ahead and find a space where you can write down some examples. Let's start with our fractions. If I wanted to convert the fraction 7/8 into a decimal, remember that our fraction bar means division. We're going to take our top number 7 and divide it by our bottom number 8. You'll notice as you go to divide, 8 divides into 7 0 times. So in order to get the decimal, we need to add our decimal and continue our problem by adding zeros. At this point, we can decide that 8 goes into 70 8 times without going over. That's 64. We place that below to subtract. We get 6. Since we still have a remaining number, we want to continue the problem by adding another 0. 8 goes into 60 7 times without going over. That's 56. Place that below to subtract. We still have 4 remaining. Add another 0. 8 goes into 40 5 times. 8 times 5 is 40. At that point, we have nothing left. If my decimal would have continued, we usually say stop at the third number after the decimal, the thousandths place. So even if I would have had something left down here, it's okay to stop the problem at this time. This told me that 7/8 as a decimal is 0.875. Let's try an example where we have a whole number out in front. 3 5/12. Our goal is to get the fractional part as a decimal, and we also want to include the whole number. But we know that if we were to go to write this as a decimal, the whole number out in front would not change, so that would stay a 3. Now we're going to use the same process to convert 5/12 into a decimal. This literally means 5 divided by 12. So we're going to set up that problem off to the side. 12 cannot go into 5, so we're going to add our decimal and 0. 12 can go into 50 4 times without going over. That's 48. I set that below to subtract. I get 2. Continue my problem. Add another 0 and bring it down. 12 goes into 20 1 time without going over. Place my 12 below to subtract and I get 8. Add another 0 to continue the problem. 12 goes into 80 6 times without going over. That's 72. Subtract 80 minus 72 and I get 8. At this point, my problem did not stop nicely, and if I were to continue going, the decimal would continue. You may notice that you ended up with another 80. That's going to tell us that we're going to keep, our 12 is going to keep going into that 86 times. So at that point, you may recognize that the 6 is repeating. On this example, if you just put 416, I would also probably accept that, but technically that 6 would continue on so that you could put that line over the 6 part of the decimal. That's converting our fractions to decimals. The other conversion we want to talk about today is converting decimals to fractions. If I gave you a number like 1.6, think about how we could write that as a fraction. The 1 would be the whole number out in front, and our focus would be getting this 0.6 or 6/10 written as the fraction. 6 would be my numerator, and then we'd have to decide what the denominator would be. When you hear me say that decimal 1 6/10, think of that number you hear. 10 for tenths. Whenever we're working with just one digit after the decimal, we're always going to place that one digit over a 10. The last step would be simplifying. What could we simplify 6/10 to? Well, both 6 and 10 can be divided by 2. That would simplify the fraction to 1 3/5. That is simplest form, my decimal converted to a fraction. Let's try one where we have two numbers after the decimal. 8 and 24 hundredths. Just like with our first example, our whole number will stay the same out in front. Our decimal part will be the numerator of the fraction. Think about what number you hear when I say this properly. 8 and 24 hundredths. You heard me say hundredths. Whenever we're working with a 2-digit decimal, we're going to place it over a 100. Last step would be simplifying. 24 and 100, they could be divided by 2 or 4. If I divide them by 4, I get 6 over 25. At that point, I can't go any further, so 8 and 6/25 would be our simplest form. Maybe you're feeling confident and could try this one on your own. If you feel that way, pause the video and try it now. 3 and 235 thousandths. Just like with our last two examples, the whole number stays the same. We take our decimal part and place it as the numerator. Think about when I say this decimal properly. 3 and 235 thousandths. What number do you hear for the denominator? 1,000. Whenever we're working with a three digits after the decimal, we place that over 1,000. Last step would be to divide. I'm going to start by dividing by 5. When I divide by 5, I get 47 as the numerator. And 200 as the denominator. At that point, 47 doesn't have many factors, so I think I am in simplest form. All right, you guys, check in with your teacher if you have any question about these skills.